Do you feel the vibes?
All right, so when we talk about trigonometric identities, what we're talking about is basically equations that, there's a left side and a right side of an equation, and they basically put together two trigonometric quantities that are equal, and that becomes a trigonometric identity. So for example, like a lot of these, you already know, you just never knew that they were called trigonometric identities. So for example, you know that sine of theta is 1 over cosecant of theta, right? You know this. Now, when you write it like this, sine of theta equals 1 over cosecant of theta, the whole thing becomes an identity. So all of these are called the reciprocal identities. You know that cosine is 1 over secant, tangent is 1 over cotangent. So all of these things are the reciprocal identities that you already know. Cosecant is 1 over sine, secant is 1 over cosine, and so on. Now, we also have the quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. Is there anything in here that you have not seen before? No. We're just calling it identities now, but there is literally nothing here that you have not seen before. Fabulous. So, in other words, if you are given sine theta, cosecant of theta is the reciprocal. For example, if sine of theta is 2 over 3, then what's cosecant of theta? 3 over 2. That's it. All right? Now, the problems are usually not going to be that basic, but we're going to start with the basics. Okay, so you might be asked to find the indicated values like this. If cosine is 3 over 4, find secant of theta, and you would say secant of theta is 4 over 3, okay? It's just as simple as that. You're using a trigonometric identity. Fabulous. Okay, secant of x is 5 over 4. Tangent of x is 3 over 4. Now, this is one level up. This is a two-stepper. So, you have to say what you're given and what you need to find, right? So this is what you need to find. So you have to find a way to connect sine of x to what you're given. Okay? So, all right. So you have tangent of x. You need to find sine of x. You have tangent and secant. You need to find sine of x. So you know that tangent is kind of like a composite thing, right? You know that tangent is sine x over cosine x, right? And you need to find sine of x. So maybe what you can do is, you need to find sine, right? You can multiply both sides of this by cosine x. Now the cosines will cancel, so what you have is sine of x is equal to cosine x tangent x, right? Yes? Okay, now sine of x is equal to, okay, tangent of x we know is 3 over 4 times, but do we know what cosine of x is?
Yeah.
What? It's the reciprocal of the secant, 4 over 5. Oh my goodness. So then the 4's cancel. So what's sine of x then? 3 over 5. Wasn't that lovely? Wasn't that so cool? Yeah? Yes. Yes, yes, yes. You're shaking your head left, right. When you really want to shake your head up, yeah, I mean, right? Huh?
I'm not doing shake left, right.
I mean, I'm not going to name names.
I will.
Because they'll name them for themselves.
It was just a little.
Yeah, it's new. It's new. So the thing is, sometimes, so take a look here at this unit circle. Right? Take a look at this unit circle here. You have the right triangle here, right? So these three sides here, we have, the x, the y, and then we have the hypotenuse, right? So using the Pythagorean theorem, right, the vertical side is y squared plus x squared is equal to 1 squared, right? But we also know that in a, with the right triangle, the vertical side is always sine, right? You guys remember that? Vertical is always sine. So it'll always be sine of theta squared and then cosine of theta squared. Okay? So another way of writing sine of theta squared is sine squared theta like this. And cosine squared theta like this equals 1. So from the Pythagorean theorem, y squared plus x squared equals 1, we get sine squared theta plus cosine squared theta equals 1. Now, because this came from the Pythagorean theorem, this is called the Pythagorean identity. And it is really the VIP of trigonometric identities. It's the Pythagorean identity. I mean, it's like, I don't know, it's like the Drake of all identities. Like, this is it, like it's like it, right? Yeah, it's huge. All right, it's the Pythagorean identity. Now, it's got 3 forms, right? This is definitely the main one. Sine squared theta plus cosine squared theta equals 1. But now, it's also got some buddies, right? So, its buddies are, look, don't switch the page just yet. Let's take this one, sine squared theta plus cosine squared theta equals 1. Now, just for fun, I'm going to divide all of these by cosine squared theta. Huh? No, I'm just playing around. I'm just having fun. Just go with me. Just go with me. Okay. So, now, what's sine over cosine? Tangent. But sine squared over cosine squared, that's tangent squared. Okay? So this will be tangent squared theta. And then plus, what's cosine squared divided by cosine squared? 1 equals, what's 1 over cosine? Secant. And then if it's squared, it'll be secant squared theta. Okay, so look at this. Look at this. Do you see how it's this other identity in the box? Do you see that? So now if you did the same thing but with dividing by sine, you get this other identity. So the Pythagorean identities come in 3 versions, just like the law of cosines came in 3 versions. Remember, a squared equals this, b squared equals this. It's a similar thing. They come in 3s. Now, okay, Mia, you had a question.
Yeah.
Oh. What was it? I'm curious that I answered.
I was going to ask what if you divide by sine.
Oh, yeah. See, I did answer. Yeah. It's all up here. Yeah. It's like an encyclopedia of knowledge I'm spewing at you. Yeah. I know. Huh? I know. I love trigonometric identities. Early in the morning, it is like the best way to start your day.
Yeah. Wait.
It rhymes too. I know. There is no better way, honestly. Okay, so now, huh? Okay, so now these Pythagorean identities, are not like solidified entities, right? It's not like sine squared plus cosine squared equals 1, and it's not like a solid like rod that you can't like move around. No, they're like flexible, and you can move each of the entities to the left side, to the right side of the equation, and so on. So that's what we're gonna do right now. So we're going to, in part A here, solve this identity for sine squared theta. All right? So I'm going to just write this here. Again, I'm just going to rewrite it. So it says sine squared theta plus cosine squared theta equals 1. And I want to solve it for sine squared theta. That means, what should I do with this cosine squared theta? But how? What am I supposed to do to it? No, because it's sine squared plus cosine squared. So subtract. So minus cosine squared theta minus cosine squared theta. So finally, this becomes sine squared theta equals to 1 minus cosine squared theta, right? This is important because later, right, we're going to have to like rearrange these identities to fit in the context that we want, okay? All right, this one, we're going to solve it for cosine squared theta, right? So we're going to solve this for cosine squared theta. So what should I do with cosine squared theta? Subtract, yes. Slay. Do we say that anymore? Is that like 2002? Is it like 2023? Oh no, what am I supposed to do? Oh no, I lost my star stuff.
Oh gosh.
That went straight to the heart.
Huh?
That went straight to the heart.
Why does it matter if it? Because you can't have negative cosine.
What? No, because it,
No, if you were to subtract.
because it says to solve for cosine squared theta. Yeah. Okay. Okay, now this one. This is, okay. So this one is saying to solve for 1 minus sine squared theta. So this one, I'm actually, you know what? I'm just going to write this one over again. Sine squared theta plus cosine squared theta equals 1. So this one, I'm solving for 1 minus sine squared theta. So I want 1 minus sine squared theta on its own. So how do I do that? Yeah. Subtract sine squared theta, right? Because I want one side of the equation to say 1 minus sine squared theta. So cosine squared theta is equal to 1 minus sine squared theta. Again, right now, this seems like it's so pointless what we're doing. But later on, we're going to be in the middle of a problem, and it's going to call for a substitution that's going to want you to do this. Okay? Mm-hmm. Mm-hmm. No, that would be sine of theta. Yeah, it does make sense. It's math. Everything makes sense. Yeah. So if sine of theta is a half, this would be a half times a half, so a quarter. Yeah. It's very cool. Math is so cool. Yeah. Yeah.
Math is really cool.
No, it does not. You can always count on it. Yeah. Oh, I didn't even notice that. Cool. Thank you. Yeah. I didn't even notice that. That just happened. Yeah. Yeah. That's the thing I like about math, right? Because when the math rules say this is supposed to end up in a certain way, it's always going to end up a certain way. And that's just, it is. If you do it right. Correct.
Yeah, usually the only time we have to confuse is when it's units.
So you blaming your bad grades on this one?
No, on himself. I'm never wrong.
Oh, I thought you were saying like the different I thought you were saying like the
Huh?
like the wrong part.
Well, in all honesty, I should have rewritten that problem.
It's alright, we forgive you.
Thank you. Yeah. Okay, solve the identity for cosine squared theta minus 1. So let's rewrite this. So now we want this. Cosine squared theta minus 1. Now this is a two-stepper again. Okay, so first let's do minus sine squared theta because we don't want the sine and the cosine together. So let's do minus sine squared theta. So cosine squared theta equals 1 minus sine squared theta. Now, okay, we still want cosine squared minus 1. So now we're going to do minus 1 minus 1. So we're going to get cosine squared theta minus 1 equals negative sine squared theta. Okay? What do I think about that? I think it's perfectly fine. Is the negative in front of the sine square bothering you? Yeah. 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 You know what? It's okay. It's okay. Because when you solve for x, sometimes it's negative 3, sometimes it's positive 4. So that's okay. And sometimes when you find sine of theta, sometimes it's positive root 3 over 2, sometimes it's negative root 3 over 2. So that's okay. We're not going to be judgy. That's fair. Yeah. Yeah, don't discriminate. Yeah, don't judge a problem by its sign. Ah. Yeah. 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 Okay. So, moving along. Moving along. Okay. Things are gonna start. Okay. All right. We're gonna turn up the dial a little bit. Okay. Use the given information to find the required quantities. So, we have cosine is 1/3, and we are told tangent is less than 0. Okay. Okay, so we need to find sine of theta. I've broken it down into steps for this first problem. Step 1 is use the information to find the SIGN sign of the functions to determine the quadrant. So, on the first hand, we are told cosine is 1/3. From that, we say cosine is positive. Okay? So, remember this. All students take calculus. So if cosine is positive, we put a plus where cosine theta is positive. So where is cosine positive? In which quadrant? This one and the fourth. There's going to be 2 where cosine is positive. Second thing we're told is tangent of theta is less than 0. This means less than 0 means tangent of theta is negative. So now you put a negative where tangent is negative. So where is that? Here and here. Yeah, but that's where tangent is positive. So it's negative in those two quadrants. Now, if you do this correctly, there's always going to be one quadrant where you're going to have two symbols. In this case, this is the quadrant where you have two symbols. So now, it's this quadrant, right? So that means our angle is in this quadrant. So we are working in quadrant 4. Okay, now we are given cosine and we want to find sine. We want to find a trig identity that most closely relates the quantities you have and you need to find. So we have cosine, we need sine. So what identity relates sine and cosine? No. Okay, so tangent will have tangent, sine, and cosine. That's 3 of them. You just want 2, one that you know, one that you don't know. So that's this first one, okay? So we're going to use sine squared theta plus cosine squared theta equals 1. Okay? Okay, so what do we need to find? Sine squared theta. So why don't we solve this for sine squared theta? Minus cosine squared theta. So sine squared theta equals 1 minus cosine squared theta. So sine squared theta is equal to 1 minus, what was cosine? 1/3 squared, right? Because it's cosine squared. Yeah.
Is this like fine with the cosine? Is this sine and theta? Does it say sine squared?
No, just sine. Because look at what we're going to do now. So now sine squared theta is equal to 1 minus 1/9. So sine squared theta is 9/9 minus 1/9, right? That's 8/9. Now, I take a square root of both sides. So now let's go over here. Sine of theta is equal to, when you take a square root of both sides, plus or minus root 8 over root 9. So sine of theta is equal to, okay, now we're at a fork in the road. Do I choose the plus? Do I choose the minus? That's why we had to look at the quadrant. We're in this quadrant. In that quadrant, we're looking at sine. In this quadrant, is sine positive or negative? Negative. So you choose the minus. Do you see that? So it'll be negative. What's root 8 these days? It's 2 root, ooh, nice. 2 root 2 over 3. So that is your answer. Whew. And now it says to find tangent of theta. So now, what do I have? I have cosine, I have sine. I can find tangent, because what's tangent? Sine over cosine. So, yeah, so tangent of theta is sine of theta over cosine of theta. So, it's negative 2 root 2 over 3, 1 over 3. So look at what happens if you have two fractions on top of each other. If they have identical denominators, they cancel. And then you have negative 2 root 2 over 1, negative 2 root 2. Just like that. Okay. We're going to do one more of this. Okay, so this one I haven't outlined the steps, but we're going to follow the same procedure. Okay, so we have cotangent is 2. Cosine is less than 0. We need to find sine and cosine. Okay, so let's first fix the quadrant. Okay, so cotangent is 2. So cotangent is positive. Cotangent is like tangent. It's positive here and here. Cosine is less than 0. Cosine is negative where and where? The second and third. So you see, it's this, there's always going to be one quadrant.
Is it never going to be in the first quadrant?
It can be. It can be. Okay, so now, okay, we have cotangent. We need sine or cosine. Okay, so let's go here. Your best bet is one of these. If you have cotangent, I would do this. So if you have this, it gives you cosecant, which is like sine, right? So your best bet is this one. So why don't we use this one? So cotangent squared theta plus 1 is cosecant squared theta. Okay, why don't we just put in the numbers here? Cotangent is 2 squared plus 1 is cosecant squared theta. So how much is this whole thing? 5 is cosecant squared theta. Take a square root, take a square root. So cosecant of theta is plus or minus root 5. So am I going to take the positive or the negative? Are you sure? Are you sure?
Cosine, yes.
I want somebody to be sure. Cosecant is like sine. Are we going to negative? So cosecant of theta is negative root 5. Now, that's fine, but I need sine. Sine of theta, negative 1 over root 5. Okay, now I need cosine. So, I have cotangent and sine. I need cosine. So I can use right? Cotangent of theta is cosine over sine, right? So if I want cosine, I can multiply both sides by sine. So cosine is sine times cotangent. So what's sine? Negative 1 over root 5. Cotangent is 2. So cosine is negative 2 over root 5. Okay, lastly, this is very little. So even in odd identities, so if you have sine or cosine or tangent, and then the angle inside is negative, okay? If you have sine of a negative angle, the negative comes out. If you have tangent of a negative angle, the negative comes out. If you have cosine of a negative angle, the negative disappears. So look, cosine of negative pi over 3, the negative just disappears. That's just the same as cosine of pi over 3. Yeah. Sine, and then you just do it like you were doing like yesterday with the, or the other day with the maze. Was it yesterday? Yeah, with the maze. So cosine of pi over 3, that would just be 1/2, right? On the unit circle, remember you were doing it with the maze. Sine of negative 45. So now if it's the sine, it comes out. So it'll be negative sine 45. So it'll be negative 1 over root 2. Okay? It just comes out. So tangent of negative 7 pi over 6, it comes out. So it's negative tangent 7 pi over 6. Okay? Yeah, it'll be negative 1 over root 3. Okay? This one, it comes out. Cosecant is like sine. It comes out. Now look at what happens here. Negative cosecant 5 pi over 3. Okay, where is 5 pi over 3? It's in this quadrant. So this is negative 5 pi over 3 is in this quadrant. So what's cosecant of 5 pi over 3? The secant of pi over 3 is secant like sine or cosine? Cosine. Of 5 pi over 3, it's cosine of pi over 3 is 1/2. So the secant is 2, right? In here, okay, so, oh no, I'm sorry, this is sine, it's not cosine. I'm so sorry. I'm sorry. Cosecant is like sine. So in here, it's negative root 3 over 2. Okay? So the cosecant here is negative 2 over root 3. So then the negatives would cancel. So it would be 2 over root 3. Okay? All right. So you have a worksheet for this for Monday.
Press start.